everyone! Welcome back to integralcalc.com. Today we're going to be doing another example of velocity and acceleration vectors. The function that we're given is r of t equals e to the 2t times I plus e to the negative t times j, and they've asked us to find the velocity and acceleration vectors at the point where t is equal to 0. So remember that with velocity and acceleration vectors, we're going to find the first derivative and then plug in t equals 0 to get the velocity vector, and then find the second derivative and plug in t equals 0 to get the acceleration vector. So let's go ahead and start working on our first derivative. Remember that when you're taking the derivative of e to the t, the derivative is simply e to the t, but when we have this coefficient out in front here, this 2, to take the derivative, we multiply the coefficient out in front of this term. So we just take the 2 and we multiply this whole thing by 2. So the derivative of e to the 2t, as you can see over here, is 2e to the 2t. Now keep in mind that when we're taking the derivative of this function and we've got I and j involved, we can more or less completely ignore that I and j are even there. If you block them out, just ignore that the I is here and ignore that the j is here, we can take the derivative of this function with respect to t and get the right answer. So notice that when I took the derivative of e to the 2t, I completely ignored that I was there, just took the derivative of this first part that involved t, left the I alone, and we're good. So taking the derivative of the second term, I'm going to ignore j, so I'm just looking at e to the negative t. And again, same as the first term, normally the derivative of e to the t would just be e to the t, but I have this negative sign here, in other words a negative 1, as a coefficient on the t. So I need to multiply negative 1 out in front of this term here. So what that's going to do when I multiply this whole thing by negative 1 is change this sign in the middle from a positive to a negative. So you see I end up with a negative here, and e to the negative t just stays the same. As does j, because we completely ignored it. It doesn't go away, it stays here in the problem, but in terms of taking the derivative, we don't have to consider it. So the I and the j stay there, and that's our first derivative. So now, to find the velocity vector, we're going to plug in 0 for t and simplify. So we plug in 0 for t, and obviously we're going to plug it in both here, and when we simplify this, we'll end up here with e to the 0. Remember that anything raised to the 0 power is just 1. So we'll have 2 times 1 times I, which will simplify to 2I. And here as well, we'll end up with e to the 0. Anything raised to the 0 power is 1. So this whole first part here is just going to simplify to 1. So we'll end up with a minus j. And that's as far as we have to go. This represents our velocity vector. So the first half of our problem is done. And now to move on to acceleration vector, we take the second derivative, and we'll be working from our first derivative here, not once we started plugging in 0, but our native first derivative of r of t, r prime of t. So we're going to be taking the derivative of this function here, and when we do, remember that we'll be multiplying this coefficient on the t, this 2, out in front, just like we did with our first derivative. So we'll end up with 4e to the 2t, and the I stays there. Remember, we can ignore it for the purposes of taking the derivative. It's just going to hang out right where it is. To take the derivative of this negative e to the negative t, we'll take the coefficient on the t, multiply it out in front. We'll have a negative times a negative, so this will turn back into a positive. As you can see here, we have a positive, and the exponent stays the same as it always does whenever we're taking the derivative of something, including the number e here. So we end up with plus e to the negative t, and the j hangs out right where it is. So now we'll plug in t equals 0 to start working toward our acceleration vector. So we plug in 0, and of course we'll end up with e to the 0, so that will be 1, which will leave us in our first term here with 4i, and in our second term we'll end up with e to the 0, so this whole coefficient here in front of the j turns into 1, so we'll end up with plus j. And therefore, our acceleration vector is represented by 4i plus j. And putting those two together, this velocity vector here and acceleration vector here, we get our final answer for the problem. So I hope that helped you guys, and I'll see you in the next video. Bye!